Hello everyone, this question is about trigonometric equations. Express 5 sine theta plus 12 cos theta in the form r cos theta minus alpha. R is positive, alpha is in this first quadrant. So first of all, because of cos theta minus alpha, we're gonna need the MF19 compound angle formula for cos. So since we have minus here, we use the minus. So minus plus cos alpha minus theta minus alpha, cos theta minus alpha equals cos plus sine. So now we apply the formula. We have 5 sine theta plus 12 cos theta equals r cos theta minus alpha, and using this MF19 formula, we use this and we expand, we open up the square brackets, we have r times, and now we compare the cos theta. So if we look at the variable cos theta, so cos theta is the variable in this case. The coefficient on the left is 12, on the right it is r cos alpha. So we have one equation, 12 equals r cos alpha. And for the variable sine theta, we have the coefficient on the left 5, on the right r sine. So we have the second equation. Now if we divide both equations using this MF19 formula, we cancel out and we get sine over cos, which is tangent, and using inverse tangent we can find the angle alpha in three significant figures. And if you look at the MF19 formula, the Pythagorean identity, cos squared plus sine squared equals 1, we can square the r cos and the r sine. Again, r cos is 12, r sine is 5 from here. So we square r squared cos squared, r squared sine squared, and we can pull out the r squared, factorize, and again this is 1 because of the MF19 formula, which means the r is the square root of, use your calculator, you get 13. So we have the r and the alpha. This is the final answer. Now hence solve the equation. So first of all, from the first part we know that the r is 13 and the alpha is 0.395. So from here, and in the next part here, instead of theta they use 2x. So if you replace the theta with 2x, of course you have to replace this theta with 2x also. So now we know that this guy is 6, so we're going to replace this left hand side with 6, and then we can divide 13 both sides. And to find the base angle, we use inverse cos. We have to use inverse cos something positive. So using a calculator we get this in 3SF. And if you look at the domain in the question, it says from 0 to pi here. So 0 to pi is 4x. The angle we are dealing with is 2x minus 0.395 actually. So actually we have to modify the domain. So from the original domain we multiply by 2, and then actually we have to subtract 0.395 from the three expressions here. We have 2x minus 0.395, 2 pi minus 0.395. So we use this modified domain. Now since the value of cos, so this is cos something, equals something positive, this means we have to use the quadrant 1 base angle, or we can use the quadrant 4 because cos is positive in quadrant 1 and quadrant 4. So 2 pi minus base angle. So that's all we can use for this domain. So 2x minus 0.395 can be the base angle, quadrant 1, which is 1.09, and 2 pi minus base angle. So 2 pi minus 1.09, use a calculator, we get this. And then we add 0.395 to both sides, and then we divide both sides by 2, and for the final answer we can use 3SF for angle in radians. Alright, I'll see you again next